Now let's talk about the problem of the day. During this time, we'll think together about how to represent and solve this problem and what it teaches us about math. When I ask you questions, please do make sure to answer out loud, just like you would in school. Let's tackle each set of facts one at a time. What do you notice about the equations in group A? Say it out loud. Yeah, all of these factors are even. So what does it mean if a number is even? Say it out loud. Yeah, a number is even if that number can be divided into two equal groups. Okay, so what do you notice about the products we get when we multiply an even factor times an even factor? Say it out loud. Right, the product is also even every time. So let's think about why this might be the case. Here's a visual representation of multiplying two even factors, 6 and 4. Why is it true that when both factors are even, the product will also be even? Say it out loud. You probably noticed that if we have an even number of groups with an even amount in each group, then we are just combining even numbers together. So we're always going to have two equal groups. For example, in this problem, 4 plus 4 plus 4 plus 4 plus 4 plus 4 equals 24. 24 is even because every number that we're adding together to get it is also even. Okay. Great. So if we have equal groups with an equal amount in each group, our total will always be even. Read this with me. Get ready? Go. Even times even equals even. Great. So now let's look at our next set of problems from the problem of the day. What do you notice about the factors and the products in these problems? Say it out loud. Right. All the equations have one even factor and one odd factor, and the product is always even. Okay. So here's an example of multiplying one odd and one even factor. 2 times 7 equals 14, or 7 times 2 equals 14. So why does multiplying one odd and one even factor always result in an even product? Say it out loud. This is really interesting. If we have an odd number of groups with an even number in each group, we are combining even numbers, which will result in an even total. 7 times 2 is 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2 equals 14, which shows us that repeatedly adding an even number will always make for an even answer. If we have an even number of groups, with an odd number in each group, we will always have an even total because two odd amounts added together will make an even amount. 2 times 7 is the same as 7 plus 7 equals 14. Combining two odd numbers equals an even number. Huh. Okay, so if we have even groups with an odd amount in each group, or odd groups with an even amount in each group, the total will always be even. Read this with me. Get ready? Go. Even times odd equals even. All right, so what about our last group? What do you notice about these factors and products? Say it out loud. Right. Both factors are odd, and the products are also odd. Putting O for odd over each one. Okay, so here's an example of that. 9 times 3 equals 27. Why is it the case that multiplying two odd factors will produce an odd product? Say it out loud. Yeah, the product is odd because we are combining an odd number of groups with an odd amount in each group, which is going to result in an odd number. 9 groups of 3 is adding up to an odd number of times. That makes an odd number. We can see it here. We're adding an odd number of times. We get an odd number. So, if we have odd groups with an odd amount in each group, the total will always be odd. Read this with me. Get ready, go. Odd times odd equals odd. Great. When you're looking for patterns in multiplication, you can think, are my factors even, odd, or both? Go ahead and click the arrow to move to the next slide.